It all starts with a massive block of high-grade military steel alloy, engineered to withstand extreme kinetic forces before impact. The massive raw casing begins its long journey through the factory floor, moving toward the primary processing zone. Digital verification confirms the production profile for this unit.
Verified. We are clear for the thermal cycle.
Proceed. With the serial tag verified and logged, the casing is sealed inside the industrial furnace to undergo extreme heat treatment. Intense thermal conditioning realigns the molecular structure of the steel, dramatically increasing its tensile strength and durability. Emerging at scorching temperatures, the glowing core is immediately handled by heavy automation systems to prevent rapid cooling.
L crescent. The laser ditter measures to within microns, compensating for Thansher, precise diagnostic,
Compressing the metal fibers for unmatched armor-piercing capabilities. Controlled rapid quenching locks the crystalline grid of the forged alloy, transforming raw metal into an ultra-dense ballistic shell. Next up is a critical straightness evaluation, ensuring the lengthy kinetic body does not possess even a micrometer of structural warp.
With the structural dimensions cleared by the verification team, the shell advances to the automated milling line.
Massive mechanical clamps lock the high-density component in place, preparing its outer shell for extreme precision lathe operations. Industrial enclosures seal the workpiece, while internal cutting systems rev up to high rotational velocities under an automated coolant flood. Computer-guided tungsten carbide tools shave off the rough forging skin, revealing a pristine, aerodynamically perfect surface profile.
The main internal chamber is bored to exact volume parameters, finishing the initial preparation phase with absolute precision.
Entering the refinement stage, the pristine steel structure undergoes an intense, deep cleaning phase to eliminate any manufacturing residue. Bubbles indicate the acid is actively dissolving iron oxide scale. The oxidation traces disappear, exposing the clean base metal, prepping it for future protective coatings. The mixer spins at hundreds of RPM, ensuring complete homogenization of the energetic compound. The digital pipette delivers microliter accuracy. Advanced molecular analysis checks the purity profiles of each batch, ensuring stability parameters strictly meet defense specifications.
Now moving into the high containment filling zone, the heavy structural body is sealed into position by automated systems.
The molten energetic payload is cast directly into the hollow core under continuous ultrasonic monitoring to eliminate internal air pockets.
Continuous automated vibration consolidates the filling, ensuring a uniform mass distribution across the entire length of the component.
Robotic thread cutters machine high-strength internal grooves at the nose collar, prepping the structure for heavy hardware integration. The automated assembly arm positions the heavy, high-strength steel nose cap, aligning the mechanical mating threads precisely.
Aerospace-grade alloy steel bolts secured. Peak torque data transmitted to the central database. The assembly is complete.
Next, the sealed structure enters the non-destructive testing vault for a high-energy radiographic inspection of the internal core. The radiographic data confirms flawless material density and absolute structural integrity across the shell body. The structure integrity is verified.
With internal diagnostics cleared, the verified payload is hoisted into the high-durability external surface preparation cell.
Automated shot blasting scales the exterior metal, stripping old surface tension and creating an ideal anchoring profile for tactical finishes. The advanced finishing booth applies an even layer of military spec coating, concluding our core refinement phase with precision shielding. The coating is baked for maximum durability, providing a standard military finish. A laser etches identification data, followed.
At the integration floor, assembly cells prepare the specialized guidance components within an ESD-protected high-precision clean zone.
Advanced robotic picking systems drop microcomponents onto precision logic subassemblies, securing connections using machine vision alignment tools. The logic assemblies are hermetically sealed inside rugged flight-proof enclosures, designed to survive hypervelocity vibrations downrange. The control fin mechanism will eventually steer the bomb during its descent, requiring smooth, synthetic grease is specially formulated for The primary payload housing meets the guidance segment, guided automatically by twin-axis alignment lasers to match internal rails. The heavy-duty military-grade wiring harness connects the guidance systems. The worker rotates the locking ring, and the dynamic monitor verifies the link. Heavy structural control surfaces are pinned into the main chassis, secured with dual redundant safety wire links to withstand subsonic drag. The calibration signal is triggered, showing minimal angular drift. The servo motor drive generates a high-power electric winding hum. The target acquisition lens is activated next, locking flawlessly onto simulated coordinate points to verify optical flight path correction accuracy. Critical mechanical interlocks and safe-arm modules are verified, ensuring the internal energetic payload remains inert until explicit command data is received. Total mass and center of gravity metrics are measured by heavy load weight platforms, proving balance configuration fits flight envelope tolerances perfectly. The integrated unit enters the environmental stress chamber, clamped tightly onto a high-output multi-axis electrodynamic vibration test platform.
Supernuato. The vibration test subjects the bomb to forces many times greater than gravity, simulating the most extreme flight conditions.
Successfully concluding our high-tech robotics and hardware integration phase. Entering final safety verification, the unit is connected to advanced diagnostic systems to begin full structural subsystem checks. Automated software runs deep architectural memory checks, ensuring the primary flight controller code block answers instantly without execution lag. The internal inertial measurement unit undergoes precise axis tuning, calibrating spatial awareness systems to guarantee pinpoint precision. A direct physical-to-digital serial cross-check is performed, sealing the exact identity tracking history of the weapon system. Safety protocols sealed. The primary live circuit firing path simulation is now active. The digital fuse emulator registers a flawless firing pulse command, ensuring structural ordnance actuation happens exactly at target depth profile. Detached from diagnostic rigs, the fully certified ordnance receives heavy flight certified lifting hardware directly onto its structural anchor points. The custom tactical shipping container is prepped, revealing shock-absorbing composite cradles precision molded to match the weapon's massive physical envelope. With care.
The ratcheting binder uses a mechanical advantage to apply hundreds of pounds of tension to the chains. Each click of the ratchet handle represents a specific increase in tension. Heavy-duty logistics vehicles engage the transport capsule, lifting the sealed system to begin warehouse logistics transit stages. Automated facility clearance scanners scan the electronic shipping tags, logging the unit departure route in the Secure Defense Inventory log. As daylight floods the frame, the secure transport container exits the blast perimeter, moving towards the military airfield staging sector.
At the runway staging sector, the massive payload is ready. Adjusting left, hold it steady. Lock pins engaged, clear to proceed.
3, 2, 1.
The heavy transport container slides effortlessly across the deck rollers, locked securely in place.
The tactical transport aircraft is approaching the designated forward deployment theater. We are cruising at high altitude under absolute mission control parameters. Touching down at a secure forward airbase, the weapon system completes its logistics transit phase and enters the operational integration line. Inside the staging hangar, the transport container is unsealed, revealing the pristine high-density ordnance ready for immediate strategic deployment. As the protective elements are stripped away, the high-grade components are exposed to operational air conditions. Ensure all red safety pins are accounted for. The heavy strategic bomber reveals its payload bay as the hydraulic trapeze system engages to receive the ordnance.
Lift pump engaging. Steady, steady. Lock confirmed.
Secondary latch confirmed. Station armed and loaded. The payload is secure. Under the roar of full military power, the strategic bomber lifts off, climbing steeply towards its objective. Approaching the launch envelope, flight computers dump real-time GPS coordinate matrices and target density profiles directly into the weapon memory array.
Release command executed. The massive GBU 28 bunker buster detaches from the launch rail, entering freefall and accelerating rapidly under gravity pull.
With pinpoint accuracy, the weapon system locks onto the target for a direct intercept.
Target locked. The distance is dropping rapidly. Terminal velocity achieved. Impact in 3, 2, 1, 0.
Upon high-speed impact, the forged alloy nose cone slices directly through feet of reinforced concrete armor, utilizing pure kinetic energy to punch deep into the structure. Punching cleanly into the underground command vault, the smart delayed fusing module triggers the main payload at the optimal calculated depth profile. The internal explosive payload detonated with absolute devastating force, neutralizing the hardened tactical target asset. Target destroyed. Mission complete. With satellite reconnaissance confirming total target destruction, the mission profile logs a complete success.
This video is created for educational and informational purpose using advanced AI tools and human creativity. All concepts, scripting, and storytelling are independently developed to ensure originality. Visuals and animations are generated or enhanced using AI technologies such as Veo, Canva, and Group AI, while final editing and post-production are completed using CapCut and other professional editing tools. No external creator content has been copied or reused. Any resemblance to real-world environment, factories, or processes is purely coincidental. All scenes shown in this video are digitally created and do not represent real footage. This content is produced with transparency and follows YouTube monetization guidelines.